LeetCode coding challenge, and today we are going to solve our next problem statement, maximum depth of a binary tree. So let's start. Given the root of a binary tree, return its maximum depth. A binary tree maximum depth is the number of nodes along the longest path from the root node down to the farthest leaf node. So we need to find the maximum depth of the binary tree, and the maximum depth is from the top of the root node. We need to find the farthest leaf node. So let's discuss the solution and let's see how can we find the maximum depth. To solve this approach, we can use the DFS approach, in which we can use an stack to iterate over the binary tree. So suppose we start from the root node and we do the DFS traversal. So first we go to the left node, and every leaf node gives the height of 1. So this leaf node gives the height of the 1, and then we add a +1 when it goes to the root node. So for this node, the left maximum height of the binary tree is 1, height of this leaf node +1. So left max is 2. Similarly, this is the leaf node which have the height of 1. When it goes to the top, we add 1 to it. So the maximum height of these two nodes of binary tree is 2. Similarly, when we go to top, we add 1 to it. So now the right maximum height is 3. But for the left, the height is 1. When we go top, we add 1 to it. And now the left max height is 1 + 1, 2. So for this node, the left max height is 2 and the right max height is 3. But what we pass, whatever is maximum between the left max height and the right max height. So we pass the right max height, which is 3. And when we pass 3 to the top, we add 1 to it. So now for this node, the left max height is 2 and for the right side, it is 4. So we take whatever is maximum between the left max height and the right max height. So we take the 4. So 4 is the answer for this binary tree. So basically, we just need to find the maximum height between the left height and the right height for every node. And we need to find it for every node. And gradually, we need to move from bottom of the binary tree to the top of the binary tree. And for this, we can use an DFS approach. So let's do the coding part for this. What we can do, as we are saying, we are using the DFS approach. We can call the max depth function using recursion method and pass the left node. So we have passed the left node, and we are saying we are getting the left binary tree height. So left height. Similarly, we are saying again call the max depth. Now we are getting the right binary side height. So we got the left side and the right side. We also need to check as soon as we are traversing in our binary tree and our root become null, we need to return 0. So for this, so suppose for this leaf, there is no left or right binary tree. So if we are going left side or right side, if the pointer is null, we simply return 0. Now for every node also, when we are moving to the top, we need to add 1 also. The height of the leaf is 1. Height of the leaf is 1. But when we are moving top, we need to add 1 to it. So add 1 to it. Now our logic is correct, and we need to return whatever is maximum between our left binary tree and the right binary tree. So whatever is maximum between our left binary tree and the right binary tree. And now let's run the test case. So our test case is working. Now let's submit the solution. Our solution is also working. Thanks for joining the session. Let's meet tomorrow.